I have this 4-to-1 planetary gear drive from a pneumatic grinder. The output shaft shall be fitted to this spline shaft. An adapter which threads on the drill output shaft shall be fitted to the vane motor. The adapter is drilled and then tapped 1/2 inch UNF to fit the drill output shaft. The drill shaft is then used to machine the features on the other side of the adapter. First, the outside diameter is turned. It is then bored for the sun gear. The automatic carriage stop controls the depth of the bore. The great part of the vane motor was cut off. It is then turned for a press fit in the adapter. Both parts are then pressed together. The two parts were then welded, and the weld cleaned. A flat is milled to fit a wrench. The part that connects the RPM reducer housing to the drill body is turned. It is then bored through to the drill body diameter. The remaining section is then turned. This is how the adapter with the sun gear fits on the drill. Unsurprisingly, the drill body is neither round nor concentric with the output shaft. This needs to be remedied. I file teeth on the part 1 just made to improvise a hole saw. A close-fitting bar is inserted in the drill output bushing and is used to guide the hole saw to true the drill body. I use this setup to push the drill and turn the hole saw. The teeth are then removed. The housing is turned for a press fit in the connector. It fits in the connector like so. Both parts are pressed together. And then tacked welded for good measure. The housing is then bored for the gearbox housing and output bearings. The DRO is used to bore to a specific depth to form a shoulder. The gearbox and input bearing housing is turned. It is then bored slightly undersized so that the ring gear can be pressed in. The bore is widened slightly so the input bearing is a sliding fit so the thing can be easily dismantled. Once again, the DRO is used to bore to a specific depth. Perfect fit. And the ring gear is pressed in the housing. This is the heart of the reducer. The planet carrier is fitted to the ring gear. This is the output side. Then the sun gear which threads on the drill shaft. The gearbox assembly shall be pressed in the reducer housing to this depth. The front part shall house the output spindle. The output shaft is turned to 1/2 inch and then threaded to accept a drill chuck. thread gutter is turned. And the area where the chuck registers faced. The shaft is threaded to a carrier which I just machined, to machine the features on the opposite side. First, the section where the bearing shall be fitted is turned to form a shoulder. A carbide boring bar is used to bring the hole for the spline shaft to size. The spline shaft shall be pressed and pinned. It shall drive the output shaft. Next I have to open the bore to accept this boss on the planet carrier. The parts will fit like so. It is bored for a sliding fit. The lot is assembled using the planet carrier to guide the spline shaft. And the output shaft fits like so. Since the pinhole is not on center, a slot drill is used prior to drilling. And the spline shaft is pinned for good measure. Since the bearings I have at hand don't have seals, I make them from some thin aluminium. Time for arts and crafts. The front seal needs to be more substantial, so it's made from steel. It is tapped out in the same way one would make a gasket. Eventually the material work hardens and starts to crack. The bearings and gears are greased prior to assembly. The seals prevent the grease from migrating from the assigned section as the tool is operated in different orientations. The spindle is assembled and then pressed in the housing. The sun gear fits in the housing like so. The drill shaft is threaded in, to check for binding. The housing is drilled for a retaining screw. And the thing is put together. A chuck is threaded on. Let's try it with a 2-inch hole saw. As the saw goes beyond the teeth, the cut material has nowhere to go and prevents progress. The drill feels more torquey and the low RPM prevents overheating if cutting steel. This drill has the same wattage as the one modified. I am using a 2-inch hole saw and it doesn't feel happy. It is stalling and heating up. The slow-mo chews through without stalling. I would need to run cutting tools at high RPM to get the required torque to do the job, ruining their cutting edges.